Hello everyone, my name is Monica. I'm Assistant Professor, Department of Computer Science and Engineering. Data Science. My today's topic is Lexical Analyzer's role in compilation. In this presentation, we will explore the essential function of the Lexical Analyzer in compiler. The content which we will cover is introduction of Lexical Analyzer, and the role of lexical analyzer in compilation process, and how it is different from syntax analyzer, that is separation from syntax analyzer. And after that, we will discuss about tokens, lexemes, patterns. And after that, we will discuss about some errors which comes in this phase, that is kinds of lexical errors. And after that, conclusion, we will discuss. Introduction of lexical analyzer, that is, the lexical analyzer is a crucial component in compiler as well as in interpreter. It is responsible for processing the source code and generating tokens. To do this, the lexical analyzer scans the source code and identifies the lexemes. Lexemes are the sequence of characters. And after identifying lexemes, it translates them into meaningful tokens. In this presentation, we will discuss the function of lexical analyzer and how it is different from syntax analyzer. After that, we will discuss about tokens, lexemes, patterns, and handling lexical errors. Role of lexical analyzer, or we can say functions. Role of lexical analyzer, that is, lexical analyzer performs tasks like scanning, because it is also called as the scanner, scans the source code from left to right, and the task that is performed by the lexical analyzer, that is scanning the source code and recognizing the lexemes and then generating the tokens based on the language grammar rule. This language is context-free. Lexical analyzer removes the white spaces, all the extra spaces comes in the source code. It will removed by the lexical analyzer. And all the extra comments, these comments are used to understand the code. These comments are removed by the lexical analyzer. And other non-essential elements to streamline the code analysis process. Lexical analyzer counts the number of lines of the source. It interacts with symbol table. Basically, symbol table is a data structure which is used to store the information about tokens. It interacts with symbol table, which stores information about the tokens. It also interacts with error handler and also provides error messages with corresponding line numbers and column numbers. Now we will discuss how lexical analyzer is separate from syntax analyzer. Lexical analyzer precedes the syntax analyzer in the compilation process. Lexical analyzer focus on physical structure of the source code. It identifies the individual lexemes, whereas syntax analyzer checks for code's grammatical correctness. Lexical analyzer, also called as a scanner, because it scans the code and then identify the lexemes and convert them into the tokens. Whereas syntax analyzer is also called as the parser. It converts the stream of tokens into the parser. How these two terms are interact with each other, that is lexical analyzer and the syntax analyzer. Basically, lexical analyzer is the first phase of the compilation process and syntax analyzer is the second phase of the compilation process. Lexical analyzer takes as an input from the lexical takes as an lexical analyzer takes as an input source code, and the outcome of this phase is the token. And tokens are the input for the syntax analyzer, and these two phases are interacts with the symbol table. Symbol table is a data structure which holds the information of the tokens. Lexical analyzer saves the information about the tokens into the symbol table, and syntax analyzer retrieve this uh, information about the tokens, which tokens are converted into the parse with the help of the information of syntax tree. Our next topic is about tokens, lexemes, and patterns. Tokens. These are the smallest meaningful unit identified by the lexical analyzer. Tokens can be a keyword, it can be a constant or literals, it can be a identifier, or we can say the variable, it can be a object. Lexemes, they are the sequence of characters which is recognized by the lexical analyzer, which correspond to specific token type. Now, patterns, the lexical rules that define how lexemes are recognized in the source. Here, I'm taking an example. This is a line of code that is int x equals to 10 plus y. First of all, this line of code will scan by the lexical analyzer from left to right. First come int. Int is a keyword. Int is a keyword in lexical rules. It's identified as a keyword. X can be a variable or identifier. It's an assignment operator. And 10 is an integral literal, or we can say the constant. And addition, it's an arithmetic operator. And after that, y is an identifier, and then semicolon. In this table, these are the tokens, lexemes, and patterns. Each lexeme represents in the form of tokens. Let's take an example how sequence of characters converted into the sequence of tokens. This is a line of code, source code, which comes as an input into the lexical analyzer. The outcome of lexical analyzer phase is a tokens. How these line of code converts in the form of tokens, that is, first one, lexical analyzer takes its an input and scan these codes from left to right and identify lexemes. Lexemes are the sequence of characters. First one, lexemes. Lexemes are A, second one is assignment operator. Next is B, that is addition, and C, that is multiplication operator, and after that, constant 6. How it is recognized as token, lexeme represents each lexeme represents as a token. Here, A is an identifier. It's an assignment operator. B is also an identifier, or we can say variable. Here, addition is also an operator, arithmetic operator. Here, C is an identifier or variable. Multiplication is an arithmetic operator, multiple arithmetic operator. and 60 is a constant. In symbol table, the syntax in which tokens are saved, that is in the format of token name, token information which is stored in the symbol table, that is token name, and attribute value. Here it will store in the format of each token will store in symbol table in the format of this. Here, this is a lexeme A. It's an identifier. So we will write here as ID, comma 1. Next character is assignment operator. It will write as this one. And after that, the identifier 2. After that, addition operator. And then identifier 3. After that, multiplication operator. And then constant 6. It will convert it in the form of tokens as ID1. It will write as ID1 equals to ID2 plus ID3 into 60. This is the sequence of tokens and the output of lexical analysis. Our next topic is lexical errors. Lexical errors occurs when lexical errors occurs when the lexical analyzer identifies an illegal sequence of characters that does not match any valid token pattern. Common lexical errors include misspelled keyword, undefined symbols, or incorrect uses of operators. The conclusion of this topic is lexical analyzer plays an important role or the vital role in the compilation process, that breaking down the source code into meaningful tokens for further processing. It helps to identify lexical errors and ensures that the code is in the form of suitable for syntactic analysis. These are some references from where I am taking my topic. Thank you so much.